The hat table is the same way each time. It's very consistent. It works out very well. So again, remember here we had the time, here we have the amount, and here we have the stop. First half-life is 0. Now, our amount is given right here in the problem. We start with 100 grams. The number one thing forgotten is that time is a 0 when you start. So half-life is 0, time is 0, and the amount is whatever the problem tells you. For every half-life, we're going to add 1. For every amount, we're going to divide by 2. And for every time, we're going to add whatever the time is. In this case, our time is right there, 5,730 years. But you might be like, Mr. D, well, which column do I start with? You're going to use the stop to set how much you need. So my stop is 625 grams. So I'm going to start with my amount column. And I'm going to go, okay, I divide it by 2, divide it by 2, divide it by 2, and divide it by 2. And as I can see, I've reached my stop, which is good because I also ran out of space here to write. So this is where we stop. Like, you could keep going, but don't bother. This is your stop. This is what we're looking for. So then you go, okay, half-life is I add 1 each time, and for time I add 5,730 years each time. So this is 11,460, and then I just do it again for 17190 years. And I just do it again for this. Again, every time I've done this, all I am doing is I'm adding the time. The time in this case is 5,730 years, but every single one of these, all I do is add that time to the one that came before it. So it wants to know how many years. Well, here you go. There you go. There's your answer right there. This is how many years it would take for it to degrade to that. So you put a box around it and you call it done. That's it. That's all you need to do.